Good morning, students. Now, you know that we have come towards the end of this second last chapter, that is the nuclei of our syllabus. It is the second last chapter which is going on. Nuclei we are already discussing. We have discussed the mass, defect and binding energy. I told you what is the meaning of the binding energy. I have defined binding energy per nucleon, mass defect per nucleon, which is known as the packing fraction. So these things we have already discussed. Today our discussion is a very important topic regarding a very important topic, that is the nuclear fission. Nuclear fission is one of the very important topic of our syllabus of this chapter of nucleus. Actually, nuclear fission was discovered in the year 1938 by Otto Hahn and Fritz Strassmann. They were two German scientists. Otto Hahn and Strassmann, in 1938 they discovered this process of nuclear fission. What is nuclear fission? You can write. It is the phenomenon. Nuclear fission is the phenomenon in which a heavy nucleus what is the meaning of heavy nucleus? Whose mass number is greater than 230, when excited by the medium speed or slow moving neutrons, or the medium speed neutron, then it is fragmented into two parts of comparable same size, with the subsequent emission of the neutron and an enormous amount of energy. Subsequent release of the neutrons and an enormous amount of energy. I just tell you what is happening in this U-235-92, whose mass number is more than 230. This is uranium nucleus. It is here, we can say bombarded, right? It is hitting it with a considerable energy with this, and due to which it is fragmented into two parts. Neutron is a medium speed neutron or the slow moving neutron. It is fragmented into two parts. One barium nucleus, another is krypton nucleus, with the subsequent release of 3 neutrons and a large amount of energy. Just see this reaction, very important reaction. U-235-92. So it is very important to note here that the neutron which is there hitting the heavy nucleus, that should not be very fast moving neutron. It should be a moderate speed neutron or a slow moving neutron. Then only the time of contact with the heavy nucleus will be more and the penetration will be proper. It will be penetrated into two parts. This happens here, and we can see such a large amount of energy, 200 MeV, means mega electron volt of energy, is released in one fission, in the fission of one nucleus. That is to be remembered. It is very important to remember, right? This is the nuclear fission. Now after that, it was a lot of things were discovered in this. First, I will definitely mention regarding the liquid. I will discuss regarding the liquid drop model. Look, a very important model to explain the nuclear fission, that is the new liquid drop model. Liquid drop model, I first draw the diagram for this. Look at this diagram. See, I have shown here 4 figures. Just here, look at these figures. You can very easily understand. This is the figure. We can consider these as if these are the liquid drops. So, if in a liquid drop, we all know that in a liquid drop is always in its own position, in its own shape, due to the force of surface tension. We all are familiar with this. If it is disturbed, then initially it has the spherical shape. If it is disturbed, it will become the oval shape, or it is also called ellipsoidal shape. Okay, ellipsoidal shape or oval shape. Then it will be changed to another shape, that is the dumbbell shape, like this, and like ultimately it is here, it is breaks. It is breaking up into the 2 parts. Actually, this liquid drop model was visualized. It was visualized by Frankel, Bohr, and Wheeler. These 3 physicists, Jakob Frankel, Neil Bohr, very famous name, J.A. Wheeler. These 3 physicists, they actually visualized this process of breaking of a nucleus due to when it is hit by, when it is disturbed by or excited by a neutron. When the neutron will be bombarded on a heavy nucleus, it will be breaking into its parts like this continuously, just like the liquid drop. As the liquid drop is excited, it will, like this, it will change its shape. First it will be in spherical shape, we all know. It will become now a bit elongated, it will be ellipsoidal, oval shape. Then it will be in the dumbbell shape, ultimately breaks. Similarly, a nucleus also, it will also suffer from these all stages, and ultimately it will be broken into the 2 parts. Fine. This is the liquid drop model, which was visualized by these scientists. It was actually proposed in the year 1939. After that, after this liquid drop model, a very important aspect of this nuclear reaction was visualized by Enrico Fermi, a very famous name in this chapter. Enrico Fermi. Also in the same year, 1939, Enrico Fermi actually he explained the nuclear chain reaction. What is a nuclear chain reaction? I just tell you this is actually the nuclear chain reaction. This neutron here, this is here the barium. Here it is like this. It is krypton, and these 3 are the neutrons. Now these will go here. It will hit here, also it will hit here, also it will hit. Now it will be again 3 neutrons, from here also 3 neutrons, and here also 3 neutrons. Just see, as its name is, it's a chain reaction. The reaction takes place in the series of a chain, like chain. What happens? How to explain this phenomenon? To explain this phenomenon, I will say, in case of the chain reaction, suppose there is a crystal of uranium U-23592 crystal. In uranium U-23592 crystal, it will consist of a large number of uranium nuclei, a large number. A large number of the uranium nuclei is consisting, right? It is bombarded by a medium speed neutron. It is hitting it. What will happen? One barium, one krypton, 3 neutrons. According to this formula, it is coming out. These neutrons. Okay? After that, what will happen? In turn, these 3 neutrons will be again bombarded, or they will interact with other 3 uranium nuclei, due to which 9 neutrons are coming out. These 9 neutrons will again, they will be, in an ideal case, if I consider that none of the neutron is lost, in that case, these neutrons in turn, they will also, these 9 neutrons will be colliding or will be interacting with the other 9 uranium nuclei, and in this way, in multiple of 3, neutrons will be coming out, like this. From 1 it has started, then 3, then 9, then 27, then 81, and so on. What will happen? Obviously, in this case, what may be the outcome? The outcome will be a lot of energy will be evolved, because in one fission only 200 MeV of energy is released. So in so many fissions are taking place in steps, then what will happen? A lot of energy will be coming out. A large amount of the energy will be coming out. Right? Now, we have to think of it. If this large amount of energy will be coming out, then what will be the outcome? For us, we have to discuss 2 things. Number 1, how to manage these energies, a large amount of energy. And second, what should be our objective? What should be our attempt that this nuclear chain reaction will proceed smoothly? ये जो न्यूक्लियर चेन रिएक्शन है, ये स्मूथली प्रोसीड करता चला जाए, आगे बढ़ता चला जाए. So, this nuclear chain reaction must take place smoothly. It should go on smoothly. How it is possible? What should we do? Now our attempts. So, in the next lecture, I am coming to those points. Okay?